All right, so the next colligative property we're going to look at is boiling point elevation. And as the name implies here, the addition of solutes to a solvent will increase the boiling point of that solution. So if you put salt, table salt in water, it will boil at a higher temperature than 100 degrees Celsius. And how high that boiling point increases depends again on how many moles of salt that you add to that water. Now, as far as why does this happen? Well, let's go back to the original definition of boiling. Okay, well, we know that, boiling is the process of turning liquid into a gas, but when do things boil? It's when the vapor pressure of the solution is equal to the external pressure. And we just learned that solutes decrease the vapor pressure. So if the vapor pressure is lower for a solution, then it's harder to reach the external pressure. So again, we just talked about solutes lowering vapor pressure. So if the vapor pressure is lower, the same amount of heat is not going to get that vapor pressure up to the external pressure. So in order to do this, we need to increase, you need to add more energy to get to the external pressure. Now the formula that governs this is delta T, and B just stands for boiling point. So the change in the boiling point temperature is equal to some constant, a boiling point constant, times the molality. So this change in temperature is the temperature of the solution minus the temperature of the solvent, the pure solvent. And as I said, this Kb is a boiling point constant, and M is molality. Moles of solute over kilograms of solvent. So most of the problems involving this, you're just going to take some data, throw it right into the formula, and solve for something that you don't know. So let's do an example. What is the boiling point of a 0.330 molal solution of a non-volatile solute in benzene? The boiling point of pure benzene is 80.1 degrees Celsius, and benzene's Kb, the boiling point constant, is 2.53 degrees Celsius per molal. Kind of got some weird units, but that's just so everything cancels out properly. All right, so let's throw in our formula here. And what I'm going to do is expand that delta T because our unknown is actually within that delta T. And what we want to solve for is this new boiling point. So I'm going to rearrange this to solve for the new boiling point. And all I'm doing is just throwing in some numbers here. So I have the boiling point constant, 2.53 degrees Celsius per molal, times the molality, which is 0.330, plus the boiling point of pure benzene. Notice how the molality cancels out, and we're just left with units of degrees Celsius. And that comes out to 80.9 degrees Celsius. And the final thing you want to ask yourself is, does this make sense? It's a quick way to check your answer. Well, we're talking about boiling point elevation. So I would expect if I add some sort of solute to benzene, it should increase its boiling point. And so it went from 80.1 to 80.9. That makes good sense to me. So in the next video, we're going to take a look at kind of the opposite process, but using the same exact formula.